So welcome to Electronics Excellia, and you are watching Signal System lecture series. Today the topic of discussion is the convolution sum. Okay. In the previous call we have seen how the discrete time signal can be expressed in terms of the sum of the weighted impulses. Okay. So in this section we will see how the response of LTI system to any arbitrary inputs, that is called the convolution sum. Okay. So let us begin our discussion. Okay. So response of LTI system to arbitrary inputs, that is the convolution sum. Okay. We have seen that the input of any arbitrary signal x of n, that can be expressed as a sum of weighted impulses. Okay. So that is x of n equal to this one, x of k into del of n minus k. You can sum it over from k is from minus infinity to plus infinity. So this is our arbitrary signal x of n in terms of means weighted impulses. Okay. So the response of this system x of n is the corresponding sum of weighted impulses. Response means the output of the system. So let us see that. So y of n equal to transformation of x of n. X of n, we have seen that it is x of k into del of n minus k. So let us put it over here. Okay. So let us keep x of k outside. The transformation of del of n minus k. So what is transformation of del of n minus k? It is h of n comma k. So h of n comma k. So it is the h of n comma k is the response of the means shifted impulse sequence, that is h of n comma k. So h of n comma k is the response to the shifted impulse response sequences, that is denoted as h of n comma k. Okay. So now h of n comma k equal to transformation of del of n minus k. Okay. So for any means time invariant system, this h of n comma k, we know that it is a h of n minus k. Okay. So if we put this, we can get y of n equal to x of k into h of n minus k, that is k is from minus infinity to plus infinity. Okay. So this is our convolution sum formula. Okay. So we can see the for any LTI system, if the input sequence x of n and impulse response, that is h of n, are given, so we can find the output, that is y of n, by using this formula. Okay. So here this is called the convolution sum. Okay. And is represented by x of n convolve with h of n. This is the convolution integral. Okay. So if any x of n is given and the impulse response, that is h of n, is given, so we can find out the means the response of the LTI system, that is the output, by using this formula. This is known as the convolution sum formula. Okay. So to summarize the process of this convolution between x of k and h of k, that involves these four steps. So what are the four steps? First, you have to fold the h of k. So you can see that is the h of n minus k we have to get. Okay. So that is why. So you have to find out first h of minus k. So how that can be done? That can be done by means folding. So fold h of k about k equal to 0 to obtain what is h of minus k. Okay. Then you have to shift the shifting operation. So shift h of minus k by n0 to the left or right, depending upon the whether it is positive or negative. So this is our shifting operation. Next, you can multiply with x of k. Okay. So multiply with that h of n0 minus k with this x of k to find out the product sequence. So this is our product sequence actually. This is our product sequence. Okay. This is the product sequence. Okay. That is, you can write v n0 k. Okay. This is the product sequence. Next, we can see sum it over. So sum the all the values. So next, we can sum all the values of the product sequence to obtain the output. Okay. At time n equal to n0. Okay. So this is how we can obtain the convolution sum. Okay. So this is the formula for finding out the convolution sum. These are the steps. So in the next class, we'll see with some examples how the convolution can be done if the impulse response, that is h of n, and input sequence x of n will given to you. Okay. So thank you for watching this video. If you have any doubt, you can free to ask me in the comment section. Thank you.